Hello everyone. In this video, we are going to discuss about the various structures of an operating system. Now let us now first look into the different structures that are available for an operating system. There are 5 different structures, starting from number 1, simple structure. This number 2, layered approach. Number 3, microkernel. Number 4, modules. And number 5, hybrid systems. Now, these are the 5 different types of operating system structures which are available. Let's see each one in detail. Now, first, let's discuss about the simple structure. Now, if you take the simple structure, this simple structure provides the most functionality in the least space. And this is a structure that was used by the early operating systems such as MS-DOS and Unix. Now, what is shown here in this slide is the structure of an MS-DOS operating system. MS-DOS stands for Microsoft Disk Operating System. Now, the main idea behind this MS-DOS simple structure is it is used for providing the most functionality in the least space that is available. The interfaces and levels of functionality are not well separated. And this is one of the drawbacks with the MS-DOS simple structure. For example, the application programs are able to access the basic I/O routines to write directly to the display and disk device. So this kind of a freedom, that is when the application program is allowed to access the basic I/O routines directly, what happens is it leaves the operating system vulnerable to malicious programs, causing the entire system to crash if the user program fails. And this is one of the major drawbacks with the MS-DOS operating system. And MS-DOS operating system was also limited by the hardware. So this is one of the early structures which was used for operating system. Later on, Unix was developed. That also was developed based on the simple structure. Now, if you take the Unix operating system, Unix system also was initially limited by hardware. It consists of 2 separable parts. Now, we will see what are the 2 separable parts which are available. One is nothing but the system programs. So these are the system programs, and the other one is the kernel. The kernel is nothing but it is the operating system. That is what is referred to as the kernel. Kernel refers to the nucleus of the operating system. Now, when you take the first part, that is the system program, what the system programs will do is they will use kernel supported system calls to provide useful functions such as compilation and file manipulation. And when you take the kernel will consist of everything below the system call interface. So whatever you have below the system call interface will be consisting of the kernel and above the physical hardware. So physical hardware here is this is what is the physical hardware. You have the terminals, disk tapes, physical memory, and their corresponding controllers. So this is the physical hardware. So the kernel is nothing but everything below the system call interface. So this is the system call interface to the kernel, everything below this and above the physical hardware. So this is what is the kernel. Okay, so this is what the kernel will consist of. And what does that do? What does it provide? It provides the file system, CPU scheduling, memory management, and other operating system functions, and a large number of functions for one level. So this is what is the structure of the Unix operating system. Later on, because of the lots of drawbacks that were available with the simple structure, and because all the operating systems which were designed with simple structure were limited by hardware, the second structure that was developed was the layered approach. So later on, they moved into the layered approach. So now what is done in the layered approach? In the layered approach, the operating system is broken into a number of layers, or you can call it as levels, either layers or levels. So one layer will be built on top of the other layer. So if you look at this, see, level 0 is the hardware and level N is the user interface. So bottommost layer is the hardware and the topmost layer is the user interface. So what is the meaning of this? Building one layer on top of the other. The advantage is modularity. Why do we go for layered approach? It is modularity. Modularity means you develop the code in terms of modules. So if something goes wrong within a particular module, it is enough that you make changes with the module rather than and touching upon all the layers. So once we introduce the concept of modularity, automatically we will have the advantage of debugging and the verification part will become very easy. So this is the advantage of the layered approach. The third type of an operating system structure is the microkernel. Micro, what does micro mean? Micro means small. So you know that kernel is nothing but the nucleus of the operating system. What does this kernel contain? Kernel will contain the most important functions or the most frequently used functions of the kernel. So what happens is when you bring in the concept of microkernel, what is actually done is the non-essential components will be removed from the kernel and they will be moved to the user space. That is the concept behind microkernel. So what happens is most of the kernel will now be available in which space? It will be available in the user space. So communication between the user modules will take place with the help of the concept of message passing. Hence, the benefits of this kind of a structure are 4. Number 1, extensibility. Portability 2, reliability is 3, and security is 4. These are the advantages of microkernel. Now coming to the fourth structure, which is the module structure. Now the best methodology being used by today's operating system are using the module structure. That is, you develop kernel modules which are loadable kernel modules. So why do we go in for such kind of loadable kernel modules? The idea behind this is for the kernel to provide core services alone. You make the kernel modules as loadable and make them provide only core services, whereas the other services will be implemented dynamically as and when the kernel is running. And this is the most common methodology being used by today's operating system, or today's operating system are designed based on this structure. Now coming to the last structure, which is the hybrid system. The hybrid system is nothing but, what is the meaning of hybrid? Hybrid means combination of one or more together. So you have 2 or more structures put together, then you have the hybrid structure. So operating systems which will combine different structures will result in hybrid systems. Why do we go in for hybrid systems? Because we need to have better performance, we need to have better security, and we must always see that the users are satisfied. Usability issues have to be met with. And all the operating systems that are being designed today, most popular mobile operating systems, iOS and Android, are based on this hybrid structure only. So with this, we end the concept of different types of operating system structures. So let's meet in the next video. Thank you.